Yes, ma'am. Yes, ma'am.
All right. Okay, good evening, class. So yesterday we were discussing the uniformly accelerated equations. And what did we see? We saw three equations are there. V is equal to u plus at. S is equal to ut plus half at square. V square minus u square is equal to 2as. So one question we discussed and the second question you all did it by yourself. Okay, now let's come to one more question which is a very important question. So please pay attention and stop writing. I'll give you time to read this. Now, just let's discuss this first. So, all of you, please open the cameras in the class. You have to open the camera during the class. If there's any particular reason, let me know. But the meeting is already on the focus mode, so you'll not be able to see each other. So, don't worry about that. This says a motor car starts from rest and accelerates uniformly for 10 seconds. Now, whatever questions you get in uniformly accelerated equations, draw them simultaneously. Without a rough figure, don't solve these questions because things will not be clear then. See, let's say I am starting it from here. This is the A point. The car starts from rest. So initially it starts from rest and accelerates uniformly for 10 seconds. So this accelerates uniformly, let's say, to this B point, and it is accelerating uniformly for 10 seconds to a velocity of 20 meter per second. So to a velocity of 20 meter per second. Just decode the lines in terms of a figure so that a rough figure will give you the idea. So a motor car starts from rest. So I've made it starting from the rest. It accelerates, but acceleration isn't mentioned. Uniformly for 10 seconds to a velocity of 20 meter per second. This is what the question says. It then runs at a constant speed. Now it is running at a constant speed. Constant speed means we discussed uniform speed, non-uniform speed. So if it is constant speed, can anyone tell me at the C point what will be the speed? What will be the velocity if it is running at a constant velocity?
20 meter per second.
20. Very good, Sana. See, didn't we discuss this? That all the velocities will remain the same, all the distances will be the same. Uniform means the value isn't changing. Okay. So at some point it is running at a speed of 20 meter per second. Then and it is finally brought to rest. So this is finally brought to rest. Let's say this is the final point D. So it is finally brought to rest. Here the velocity will be 0. Okay. In 40 meters. Okay. So this distance CD is this S3. This third distance is 40 meter with constant acceleration. Again, acceleration isn't given. It says total distance covered is 640. Total distance means starting from A till D. This total distance that is covered is 640. This is the total distance covered, 640 meters. It says we have to find all the accelerations, retardations, total time taken. So what is retardation? I'll tell you. This is what we have to find out, and this is all what is given in the question. Now see, we'll find out everything that is missing. Let's say from A to B, we'll solve it in 10 parts. A to B part, whatever data is given in the question, we'll see that, and using that, we'll find out the missing data. Then from B to C, similarly to C to D. Let's talk from A to B. Now pay attention everyone. A to B. Initial velocity is 0. What's the final velocity from A to B? Look, the final velocity means the last velocity. The last velocity here is 20 meter per second. So final velocity here is 20 meter per second. What's the time? Time is 10 seconds. What is missing here? The first acceleration is missing. First distance is missing. Rest of the things are already given. So yes, let's start with you, Humaira. Can you tell me an equation for finding out acceleration? This is the values. These are the values present.
Ma'am, can you repeat again what you said?
I'm asking, how will we calculate acceleration? The rest of the data is given. Look, which equation out of the three you
V
think is
U
V?
by T. V minus U by T.
Yes, V minus U by T. is equal to A. Yes. Correct. Is equal to acceleration. So V is equal to U plus AT. The first equation is sufficient, as she rightly said. So everything is 1, means we are talking about the first case. Now what's the first velocity? It's 20. First initial velocity is 0 plus acceleration we don't know. What's the time? 10. So acceleration from here A1 will be 20 divided by 10, which is equal to 2 meter per second square. So what was missing here? The acceleration was missing. A1, we have got it as 2 meter per second square. What else is missing? Distance is missing here. So look, for the distance, it's better if we use another equation. Now we know acceleration, everything is there. If I use the equation, S is equal to ut plus half at square. Everything 1, 1 for the first case. See, u into t, this will be 0 because your initial velocity is 0. What will be S1 equal to? Half. What is A1? 2. What is t square? 10 square. So S1 is equal to 100 meter. S1 is equal to 100 meter. A1 is equal to 2 meter per second square. So what did we get? We have got acceleration, initial velocity, final velocity, time, and now the missing distance also we have calculated. This is 100 meter. Now let's come from B to C. Okay, Humaira was done. Yes, Sana. Sana, can you tell me what will be the acceleration in this case?
2 meter per second square.
Why? Reason?
Constant speed.
So yes, speed is constant. What is the definition of acceleration? Acceleration is, read, look at the notes.
Rate
Rate of
of change of
change of
velocity.
acceleration. Yes. So is there any change in velocity, class? Sana?
No.
No. So it means there is no acceleration. Okay. Acceleration will only be there when the velocity is changing. Here your acceleration is 0. You apply any of the equations, you will get the answer as 0. Look, from B to C, you apply anything for acceleration. Let's say we use the equation V is equal to U plus AT. V is equal to U plus AT. V minus U by T will be equal to A. 20 minus 20 divided by 10, whatever it is, straight away 0. So acceleration here, acceleration 2 will be equal to 0 meter per second square. Because velocity is not changing. Reason you don't even need to calculate and show. Reason is that there is no change in the velocity. No change in the velocity. All right, now who is there? Nabiha. Nabiha, can you tell me what will be S2? Without even calculation, I think you will be able to do that. A2 is 0. What is this much distance?
60.
60. Why?
No, sorry, ma'am. If the whole thing is 640, so
Yes.
100 plus 40 minus 640, right, ma'am?
640 minus 100 plus 40.
Yeah,
Bigger minus
540.
540, nahi, 500.
500, yeah.
Yes. Okay, correct. Very good. See, so you don't have to calculate. 640 is total, 40 taken, 100 taken. How much is left? 500. So this will be 500 meter. How to write it and show? Mathematically, we will say, see, total distance. You can calculate it using the equation also, you will get the same answer. Total distance is 640. Okay. Distance from A to B and C to D is equal to 100 plus 40, which is equal to 140. Then your distance from B to C is equal to 640 minus 100 plus 40, that is 140, which is equal to 500 meter. Otherwise also, see, acceleration is 0. You directly use the equation. Speed is equal to distance upon time. So distance will be speed into time. Do we know the time here? Okay, time is missing. So first you'll have to calculate the time using the equation. Acceleration is 0. Distance is there, speed is there. So distance is missing, speed. See, we'll have to use the equation to calculate the time. So leave it. Otherwise, what you can do, first use the equation v is equal to u plus at or any of the equations. Find out time and then directly use it. But it's of no use. Directly you can predict it from this. Let's come to C to D finally, the last one. Now here, just focus on C to D class. The body is finally, the final velocity is 0. The body is coming back to rest. It started from rest. Now it is coming back to rest. Back to rest means the body stops now. Initially for this segment, the initial velocity will be 20 meter per second. And finally the body is stopping at 0. So look what we'll get. Initial velocity will be 20 meter per second. Final velocity will be 0 and distance covered is 40. This is the data given to us. We have to calculate the acceleration. Time is given. Is there anything else given? No. Distance, speed with constant acceleration. Yes, that's it. This is what is given. So see, here distance is there, v is there, u is there. We can calculate the acceleration using the final equation. V square minus u square is equal to 2as because this is the only equation which doesn't involve time. So v square means 0 square minus u square means 20 square is equal to 2 into a3 into 40. Now this makes it minus 400 is equal to 80 into a3. What is a3 equal to? Minus 400 divided by 80. So this is directly you have the answer A3 as minus 5 meter per second square. Now look class, what is this minus sign? Minus sign, basically this acceleration is called as retardation. This acceleration is known as retardation. You can say retardation, you can say deacceleration also. What are all these? These are basically all the negative acceleration. Negative acceleration means your body is coming to rest and the velocity is decreasing. Main reason is that velocity is decreasing. This is the whole reason. What about the time then? So whenever you have this negative sign is basically indicating the body is decreasing, the velocity is decreasing, body is coming to rest. This is also known as retardation, deacceleration, both the terms are used, or you can directly say negative acceleration. Now, if you know the acceleration, let's find out the time. So what will be the time? Look, time will be, if we use v is equal to u plus at. 0 is equal to u is 20, acceleration is minus 5, t we don't know. So 20 is equal to 5t, t3 comes out to be 4 seconds. So we'll have, look class here, what is the acceleration? A3 minus 5 meter per second square. And what is the time? T3 is equal to 40 seconds did we get? No, 4 seconds. Okay, it says total time. So we have to calculate T2 also. T1 we already know from the question. T2 also we have to calculate. Here we have to calculate. See, directly we can say, I was saying here, let's not leave the time. We have to calculate the time. You know the distance. So we can say time will be equal to speed into, speed is equal to distance upon time. So from here, can I say time is equal to distance divided by the speed? Now what's the distance covered? 500. What's the time? What's the velocity? 20. So this is equal to 25 seconds. So T2 is equal to 25 seconds. Or even if you use the big equation, h is equal to ut plus half at square. Acceleration is 0, so half at square is 0. So again, it will be u into t. So t will be s by u. That is speed by distance by speed. Now the question says total time. So T2 also we have calculated. T2 was, what did we get? 500 by 20, no? So 25 seconds. Now look class. Total time taken will be 10 plus 25 plus 4. So this is equal to, this is 35, 39 seconds. This is the total time. How? T1 10, T2 25, T3 4. Now I am repeating this. If any doubts are there, please stop me. Body was accelerating, was initially at rest, then accelerating to this velocity. We used the first equation and got the first acceleration, and used the second equation to get the distance. So here everything was there. U, V, T, acceleration we calculated S. Now this velocity is remaining constant, so there won't be any acceleration. And since 40 and 100 are used here, this distance will be 500. Now if we know the distance is 500, using this formula, distance upon speed, we'll get the time as 25 seconds. Finally, the body is brought to rest, velocity is decreasing. So we use the first equation, but we use the third equation, but we get a negative acceleration. Negative acceleration indicates that the body is stopping, the velocity is decreasing, and you get a negative value of acceleration. And again, using the first equation, we calculated the time. So for the total time, we added all the times from the first one that was already given in the question, 10 seconds. Then we calculated 25 seconds. And in the last case, which we calculated 4 seconds, the total was 39 seconds. Now tell me, all of you, have you understood this question properly?
Yes, ma'am.
Nabiha?
Yeah, ma'am, understood.
Okay. Please write it, all of you. Yes, Tahura, do one thing, just take the screenshot of the question. So at least you will write it, leave a little space in your notebook. Just take the screenshot and then
Took
copy this
mark.
question. Okay. And take this also.
Done, ma'am.
Okay. Leave some space, Taura, and start writing from here. And if you need help, then at the end of the class, I'll explain you. Okay.
Okay, ma'am.
Class done or still writing?
Done, ma'am.
Done? Okay, now class, there is an equation, displacement covered in nth seconds. You understand what is meant by this. If I say, let me break a particular distance into various parts. Let's say A, B, C, D, E, F. Now, this is 0, t is equal to 0, 1, 2, 3, 4, 5. These are all the time seconds. Okay, 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. Now, I tell you that the distance from A to D is, let's say, 80 meters. Okay. And I tell you the distance from C to D, just C to D, this is 10 meters. Okay. A to D means from 0 to this 3 seconds. And CD means just this 2 to 3 seconds. You can get the equation if the time is given to you. That time is equal to 3 seconds. It means that it is referring to 0 to 3 seconds. So you'll have to calculate from this A point to this D point. That is, this will be the answer for t is equal to 3 seconds, 80 meters. But as soon as I say time is third second, nth second, first second, second second, third second, fourth second, fifth second, like this. So this means this is referring to the time just in that interval, 2 seconds to 3 seconds means this. This is when you have the time third second. So sometimes in the exam we get the value nth second. Like if I say, example, if I say fifth second, so whatever will be the distance, this will be in the fifth second. And if I say 5 seconds, then it will be from here to here completely. That will be 5 seconds. So this is what is meant by nth second. Nth second means in that particular small interval only. And when you give the time, that is from the starting. Tell me class, this difference is clear? Nth second and n second? Is it? Is it not? Should I repeat anything?
Clear,
Yes,
ma'am.
clear. What about others? Tahura, Nabiha, Humaira? Understood or not? Should I repeat? Let me know. I'll repeat it. See, when you have 3 seconds given, means not in the power, normally t is equal to 3 seconds, t is equal to 4 seconds, 5 seconds, like this. That means that it is referring to the total distance from the starting. You take u as 0 and whatever is the throughout change total, you consider that. Okay, total distance is what is taken in the fifth second. Let's say third second. It means from the starting to 3 seconds, 0 to 3 seconds is what is meant by it. But if I ask you third second means only the gap between 2 to 3 seconds. Just this distance is referred to as third second. If I say fourth second, fourth, th, nth, so that will be just this gap. But if I say 4 seconds, it will be from the starting. Okay, now got them difference?
Yes.
So for this, we have an equation. You don't have to solve anything separately. One method is that, see, if I want to calculate for the third second, if I know this is 80 meter, I can calculate this S2 and this S3. If I subtract them, I'll be able to get this distance. That is one method, but that is a very tedious process. You have to calculate 3, then you have to put the time as 2 and get the value. It's better if you just directly use the equation. Sn means the displacement at the nth equation is equal to u plus a by 2, 2n minus 1. That's it. This is the equation. What is the meaning of each variable here? Sn is what? This is the displacement covered in nth second. What is u? It is the initial velocity. What is a? It is the acceleration. What is n? It is the nth second. Using this equation directly, you will get your answer straight away in one line. Like I'll show you. Look at this question. This says a body starts from rest and accelerates at 2 meter per second square. Displacement covered in 2 seconds. In 2 seconds means 0 to 2 seconds. So body starts from rest, so u is 0. Accelerates to 2 meter per second square. Time is given as 2 seconds. Now I have to calculate the displacement. Yes, which equation will be suitable, Tahura? U is there, A is there, T is there. I have to calculate S. Which equation should I use out of the 3 equations you've studied? V is equal to U plus AT, S is equal to UT plus half AT square, V square minus U square is equal to 2AS. Yes, Tahura? Out of the 3 equations, which one will be suitable? Look at the variables. Tahura, unmute yourself. Are you there in the class or not? Yes, Tahura, are you present? Respond in the chat column in 5 minutes, otherwise you will be removed from the meeting, Tahura. So see here, we'll use S is equal to UT plus half AT square class because velocity is not there. And in the rest of the 2 velocities required, so directly we'll use this equation. Now look, this is 0. So S is equal to half, acceleration is 2. This is equal to 2 square. So distance comes out to be 4 meter displacement. Similarly, this was the first part. Second part says same thing, but time is given as 3 seconds. Okay, we'll put time as 3. Now again, S is equal to UT plus half AT square. Here UT will again be 0. S will be half AT square. This is equal to 9 meter. Now look, last part I'm getting, it is third second. Third second means 2 seconds to 3 seconds. In this gap, what is the distance? Now I'll be using the equation that we have studied right now. Sn means S3 we have to calculate. Third value, U plus A by 2, 2n minus 1. This is the equation. Now what's the initial velocity? 0. Acceleration is 2 by 2. 2 into what is n? 3 minus 1. So this is equal to, this becomes 1. 6 minus 1 is 5. So S3 comes out to be 5 meter. Now look at the difference class. This was coming 9 meter. From starting to 3 seconds. This 9 meter means from the starting till the time is total 3 seconds. The distance covered is 9 meter. And this says just at 2 seconds and between 3 seconds, the distance covered is 5 meter. Now tell me, now have you understood this nth equation, all of you?
Yeah, ma'am.
Others, Umaira and Sana, got it? Okay. Write it down. If there's any difficulty with anything, please let me know. Then we'll practice one more question from this and we'll move on to the next topic. Okay. We'll do the derivations. Derivations are also left. Please write. Can class?
Yes, ma'am.
Let's practice one small question based on this. It says that a body covers 12 meter in second. Now, class, can you tell me which equation is suitable for this? The one which we have done just now or the earlier one? Which equation? Second. Yes, Sumera, Nabiha, Sana. Which equation? Second, fourth, second. Which equation is valid here?
Sn equals u plus a by 2.
Yes, very good, Omera. The recent one, why Nabiha and Sana didn't know this? We have just discussed this. No, when you have second, third, second, fourth, second, nth second, use the new equation. Don't use the earlier one. Okay. So this says a body covers 12 meter. What's the distance? 12 meter in second and is equal to 2. And it says it covers 20 meter in fourth second. You have to find the initial velocity. You have to find the acceleration. See class, the equation as Humera said, we are going to use this one only. Sn is equal to u plus a by 2, 2n minus 1. This equation. But let's put value 12 is equal to u. We don't know. So we are going to put it as u only. Plus, what's the acceleration? Again, we don't know. So let's put it as a only. A by 2. What is n? N is equal to 2. So that makes it 2 into 2 minus 1. So this is equal to 12 is equal to u plus a by 2. 4 minus 1 is 3. So 3a by 2. If I multiply the entire equation by 2 with 2, what will I get? 24 is equal to 2u plus 3a. Right? This becomes my first equation. Just tell me, all of you, till the first equation, is it clear?
Yes.
Okay. Let me write down the second equation now. 20 and 4. So look, 20 is equal to u plus a by 2. Now, 2 into 4 minus 1. 2n minus 1. So what is the equation that we'll get? 20 is equal to u plus 7a by 2. Again, I'll multiply. Why am I multiplying it with 2? So that I get rid of the denominator 2. Otherwise, we can keep it. If you can solve the equation easily using this, you can keep it. These are just two equations with two variables. U and a, these are the variables here. Right? So you can use any method of calculation and get the value of u and a. Like I prefer to eliminate the denominators. So this will be 40 is equal to 2u plus 7a. This is the second equation. Using these two, we can calculate the value. See, 40 is equal to 2u plus 7a. 24 is equal to 2u plus 3a. Let's subtract. Let's subtract them. This becomes negative. This becomes negative. This becomes negative. The best part here is that this will be eliminated. What will this be? 26, 16. This will be 16. 16 is equal to 4a. Acceleration is equal to 4 meter per second square. I've got the acceleration. Now, if I put it in any of the equation, I can get the value of the initial velocity. 24 is equal to 2u plus 3a. 3 into what's the acceleration? 4. So 24 is equal to 2u plus 12. 2u is equal to 12, u is equal to 6 meter per second. So two equations, two variables, that's it. It's a very good question that has been repeated in most of the school exams class. Tell me, how did we calculate the value of u and acceleration? Is that clear to all three of you? Humaira, Nabiha, and Sana, properly?
Yes, ma'am.
Yeah, ma'am.
Okay, all right. Please write this question as well. Can class?
Yes, ma'am.
Okay. So see, this says the body starts from rest and accelerates at a rate alpha to a maximum velocity. Then it retards at constant rate beta to come to rest. If total time elapses t, you have to find the maximum velocity. It means the body is starting from rest, so u is equal to 0. This is the last question from this topic. It will complete this topic. From rest and accelerates at a rate alpha. Here the acceleration is alpha. To a maximum velocity, let's say some velocity v. Then it reaches a constant rate beta to come to rest. It retards at a constant rate beta. Means this is finally coming to rest, but here the acceleration is minus beta. Why minus, class? Because it says retardation. This is getting retarded. Okay. If total time elapses t, find the maximum velocity of the body. Let's say total time is t. So what's the individual time? Let's say some t1, t2. Now let's calculate from here. Let's say this is A, this is B, this is B, this is C. So initial velocity is 0. V is the final velocity. Acceleration is alpha. Let's find out t1. So if I use V is equal to U plus AT, I will get V is equal to alpha t1. So t1 will be equal to V by alpha. This is my first equation for time, but I cannot use t1. Why? Because t1 is not given in the question. You cannot use any variable that is not mentioned. Then it says the second part, v to 0. Now the initial velocity is v and acceleration is minus beta and time is, let's say, t2 and final velocity is 0. So now if I apply v is equal to u plus at, look, v is 0, u is v. What is acceleration minus beta? Time is t2. So t2 is equal to beta, t2 is equal to v. So T2 is equal to V by beta. Now, question has asked us, what's this value of velocity? You cannot use T1 and T2. You have to eliminate them because T1 and T2 are the variables that we have chosen. So we have to remove them. We can do T is given in the question. Total time elapses T. So total time means T is equal to T1 plus T2. Let's put the value. T is equal to V by alpha plus V by beta. If I take V common, I'll get 1 by alpha plus 1 by beta. Now let me take the LCM here. This will be beta plus alpha divided by alpha beta. So from here, I can say velocity is alpha beta t divided by alpha plus beta. This is what the question said. It's a very, very, very important question that often repeats in your school exams. This year also, in many of the school, this question came to find out the maximum velocity with this alpha beta. Is this question clear to everyone? How to get this?
Yes, ma'am.
Okay. Please write it.
next rule with the